Hi, this video is to walk you through how to create your circuits in Multisim, and the purpose of this video is for students that are either absent in class or you need a refresher, you need to go back and see something again in terms of building the circuits in Multisim. So what I'm doing is I'm just doing a screen recording of this, and I'm going to work through steps 3 and 4, or I guess it's technically steps 6 and 7 of activity 1.1.5, and which are to build the circuits in Multisim that are from steps 3 and 4. So that's what I'm staring at. So this is your main workspace in Multisim when you just open up a file. And hopefully I can remember how to do this in a good way. So usually I'll start by placing ground and power and all the components for my circuit and then connecting them with wires when I'm done. So if you look at, hopefully you can see my mouse. I don't know if I have like an option for you to see my mouse, but in the left-hand side, on the upper left-hand side, it says, at least it's showing up on my screen where it says place source, and we're going to click that button and it opens up our sources. So we're going to look at power sources, and we have a lot of things to choose from. We have AC power, DC power, ground, which is what we're going to place first. Yeah, so we'll place ground first, and then the D ground, that's a digital ground, but like really ground is ground. So when we're doing digital circuits, you can pick digital ground. I picked just regular ground, and this is an analog circuit anyway. So I'll select ground and then click OK, and then my ground starts floating around on my screen here, and I'll just click to place it. And what it does is it automatically like kind of sets you up for placing like ground again, but I don't need to place ground again. So if I wanted to place another ground, I would click OK in this window, and then it would just let me place another one. Now, when we do some of our digital circuits, you might want to place like 20 AND gates on your circuit, and so you're going to click OK like until you've placed all of them. I'm going to go to DC power. There's our battery. Click OK. And I'm going to go ahead and place my battery. And then I'm just going to close that out. Now notice it's defaulting to a 12-volt battery. If I double click on it, so I did a double left click on the component, and this can get a little tricky, so close that out. If you like click on like a piece of it, like you can edit a piece of it, but if you want to actually edit the component, you need to click on the actual component. It'll highlight it in that dashed blue, and then double click it, and you can see that this is a 12 volt and we need to change that to 6 volt. I went with the 6 volts because that's what we can do with the AAA batteries that we have, because we don't have our like regular power sources yet. And so I'll click OK, and it changes that to a 6 volt power source. And it says V1. If we were to place like other power sources, it would be like V2, V3. So it's going to number them, and that can come in handy. Now we need, what am I looking at? We need 4 resistors. So I'm going to come up here. Now you can have like place basic. Now from here, you can actually get anywhere. So if I click on the basic, that drop down menu, I can actually get anywhere else I need to go. So if you don't see what you want to click on in the menu, just like click on something and then you can get it from the drop downs, because I could go back to sources from here. We have diodes, indicators. We're going to use indicators instead of LEDs on a lot of our circuits. We're going to all spend a lot of time in TTL. That's your digital logic is yours TTL. But we'll go in basic, and notice some of the things that are on there. We have switches, so if you need a switch for your circuit, you would find it there. If you need a capacitor, I know we talked a little about capacitors. You'll see it there. We're going to click on resistor, and you can just place your resistors first and then edit the value of the resistors, or you can actually look for the values of the resistors that you want. So the first one I want is like a 2.7K. I don't even know if that's going to be on here. Oh, it is on here. So I can click down a 2.7K resistor, click OK. And I'm going to put that about in the location where it's supposed to be. The next one is a 10K. I can actually probably type in that window up at the top and just do a search for 10K. There it is. And you can also do what I did with the power source. So you can place all your resistors first and then edit the values of them afterwards. It's pretty nice. Next one is a 3.3K. And this one, see how it's like it's facing the wrong way? If I hit Control R, and I'm doing that with my keyboard right now, I'm just doing Control R, I can rotate it so that it's facing the direction I want. You can also rotate something after you place it. It's a little bit more awkward. So usually when you're in the process of placing your components, you'll rotate them as you're placing them. So that was 3.3K, and the last one in that circuit is 8.2. And if you don't see the value of the resistor you're looking for, you can sometimes type it in and override it. We did that this summer a little bit. And now I've placed everything that I have. Notice that Multisim automatically labels them R1, R2, R3, R4. It doesn't like matter a whole lot. Just you want to make sure that you're consistent with the schematic that you're using. And honestly, for my sanity, since there's at the time of this recording, there's 16 of you. Don't know if that number will change. And now to connect this with a wire, just if you hover over the end, you'll see like a little dot come up, and you can place it. In Multisim, this takes a little bit of getting used to. Like as you move it around, it'll automatically bend it for you. If you want it to bend in a spot other than where it's bending, you can just click and it'll kind of anchor the spot there. I just hit escape to delete that because I don't actually want my circuit to go there. And you can also change the color of your wire so it defaults to red. But like, if you wanted to change the color of that, you can right click, and I'm going to go to segment color, and you can pick like any kind of color wire you want. So I'm going to change it to black. So current color was red. You might have noticed where it said net. I'll kind of, I don't know if this will work for the net since there are resistors in here, but I'm pretty much just connecting the rest of the circuit. Now, what's a little awkward here is like if I'm hovering over that left corner of the circuit, like I need to ground the circuit, and it won't let me start like a new wire off. So what I have to do is start it at ground and then run it up, and it will connect it just fine, and it puts this joint in. You can actually place joints as well, and off the top of my head, I don't remember how to do that. I just know that I had to place joints. I will obviously remember that. Place, there it is, under the place menu. So you can place a junction. So if you wanted like a junction like there, you can place one, and that will allow you to run a wire off that point. I don't actually want a junction there. Okay, so that's how you build the circuit in Multisim. Now for step 6, it says use the voltmeter. Oh, and then you can simulate the circuit. Now, this isn't going to do anything because resistors don't do anything. But I can hit that little play button right there. And what that does is it pretty much turns the circuit on. To change the segment, I'll show you if I right click on that. I'm going to change it net color, and net just means it's going to change like that wire segment and anything connected to that wire segment. So I'll pick a different color just for illustration, but we'll pick like a blue color, and notice that it didn't just change the segment that I clicked on, it changed everything that was connected to it. That is super useful. I don't actually want it, I do want it black. It's super useful when you have different chunks of a circuit that are running different things. And what you'll do is you'll put everything in that chunk in like a particular color, and it can really help. When I was doing my training this summer, it took me into the second week before I felt like I was getting good at that. And I was really color coding the pieces of the circuit in a way that would help me troubleshoot it if if things got like off. All right, so for part 6, it says build the circuit from step 3 in Multisim. So hopefully you've been able to follow along with that. And then it says use the voltmeter in Multisim to measure the voltage drop over each resistor. Screenshot the voltage drop over one resistor and paste it into a Word document titled your name underscore DE underscore 115. So for the voltmeter, I don't even remember what the voltmeters are. There was one over there, but that's not the one I want. Place power component, place indicator. Oh, crud. Like, it's none of that stuff. Well, let's go over here to basic and see. Know if it's an indicator. Oh, it is under indicator. Okay. So let's see if we can find a voltmeter. Oh, look at that voltmeter. So voltmeter. Let's go with voltmeter V. I'm just looking at that. We have plus, minus. No, let's not go with that. That's, well, I guess it doesn't matter. Let's go with this one. Let's go with voltmeter H. Oh, horizontal. That's what, notice, you have to like notice this, because it'll give you like that weird backwards voltmeter, kind of like Tinkercad did, which side is your positive and which is your negative. Because if you hook it up like backwards to the direction of current flow, it'll give you a negative voltage. Not a big deal as long as you know that's what you've done. So when you're measuring voltage, we'll click OK. And we're going to put this, now I didn't really leave enough space at the top of my circuit to put a voltmeter. It's, yeah, this is not very good. So I'm going to go ahead, I'll put it down here. Okay. And I think I want to rotate it. So let me rotate, let's just, oh, wait. Okay, and the reason I did that was because the conventional direction of current flow is coming, like this is like my positive and it's coming around to my negative. And now I'm just gonna hook this up. So we're gonna hook it up over the resistor. So your voltmeter has to go over the resistor. And now when I hit that play button, it should give me the voltage drop over that particular resistor. So I'm starting with a 6 volt drop there, and over the 8.2K resistor, it looks like I'm getting about a 2.032 voltage drop over that. And so what you're going to need to do is measure the voltage drop over each resistor. Now you can just do 1 voltmeter and stop the simulation and just move it, or you can put more than 1 voltmeter in. So I'll show you what that looks like. Let's go ahead and go back to indicators, voltmeter. I can pick like vertical. I guess let's do a vertical because of the positioning of this one out here. I don't think I've ever used this before. And again, you want to pay attention to which is the positive side and which is the negative side. So I'll hook up my voltmeter like so. And you want to have that over like the resistor, and then now it will simulate it, and you can see how much voltage is dropping over that. So you're going to measure the voltage over each resistor. Notice how I'm saying it like you're measuring the voltage over, and you can kind of see it like over, like you're hovering over the resistor. You can't see what my hands are doing because I'm screencasting this, but like you hover over it and you measure it on either side. Okay, so that's what that's going to look like, and then you'll do a screenshot of at least one that looks like this and paste that into your document. Now for step 7, you build your circuit the same way. So for this one, I think I had you do quite as much. So we're going to build the circuit. If you hear me, I'm like flipping back and forth through your packet here. Let's like zoom out, and I'm clicking the mouse button on the center of the mouse to kind of slide the page around to see where I have some space. So for this one, this is a parallel circuit, and in the interest of integrity, I am actually not going to put the same values in there that are on your packet, and the reason I'm doing that is because I don't Not that any of you would do this, but I don't want you to pause this video and screenshot this video and submit it as your own. So I'm going to intentionally put in some different resistors in there so that the numbers will be different, and I'll catch you if you do it. Not that any of you would think of doing that, because I'm sure you wouldn't. So we need some resistors. So I'm just going to go over here to basic, and you'll get like comfortable with this, like where to find this. By the end of my 2-week training, I was really, really fast at using this program, and I could build stuff pretty quickly. But at first it takes a while because you don't know where the menus are. And it's been, when did I take my training? Like the last 2 weeks in June, first week of July. And so I'm recording this last week in August. So I don't remember everything. And I'll get better at it as I keep looking at it. But we're going to do some resistors. So I'm just going to go with this 8.2K because that's what I've got on there. And, we'll do a 10K. These are not the same values that are in your diagram. And we'll do a 470 ohm resistor, and we'll make that one. We'll do, I'm hitting Control R to like turn it, and then we'll do a 330 ohm resistor, and we'll put that one. Oh, it would be good if I hit the right key there. There, and then we needed one more. I don't know. Let's just do a 1K, and that one like is in this general location. And now I'm going to connect this. Now I had to do. Oh, whoops! I have another resistor floating there. When I did this, I had to do some stuff for like a pre-training, and I had a weird problem when I tried to measure the current. And I had to like delete all my circuits and rebuild them. And this was before I had any training. So I was just trying to like kind of figure it out as I went. I don't know. I didn't have the problem over the summer though. So I don't actually know what's going to happen here, but we're just going to connect this up, and I guess we'll see what happens. You can also change the width of your wire. But I don't remember how to do that. Maybe properties. Nope, not there. Don't do that. I don't remember how to do it because like sometimes like your wires get really hard to see. I can zoom in a little bit on this, I guess. Now notice like I can't get like a joint there, like the junction. I can get one if I run it from the resistor up there. I can get it, but I can't just generate a junction. So I'm going to come down here, and then I'll have to connect that in there, and we'll connect this to ground, and then, okay. And then I can hit that little play button, and yeah, I can hit the little play button. Oh, I built the totally wrong one. I built the one from step 5 with all the wrong resistances. It doesn't matter. Now to measure the current. So I don't have you do everything like in the original PLCW activity. You're supposed to measure the current in all of the places. So like just like when you analyze a circuit, you're supposed to find the current in each branch. It's a lot more awkward when you're doing this because you actually have to dismantle pieces of your circuit, which you don't have to do when you're just doing it on paper. So I changed it so you need to measure the overall current. And I didn't know how it was going to work. So you'll notice that there's like a thing in step 7. Find the current in the whole circuit, the overall current, and in one branch of the circuit. So to find the overall current, the best way to do that is to just place your ammeter like coming right out of the battery or going right back into the battery. If you place it like in one of the branches, like after it branches at that little junction there, if you place it in one of the branches, you're not going to get the overall current. So the safest thing to do is to place your meter like right near your battery. So unlike a voltmeter, when you're measuring current, you actually have to insert the meter into the circuit. So I'm going to I clicked on that segment of wire and I'm going to delete it because that's where I need to put this meter. I have to put it into the circuit as like part of the circuit. So we'll go ahead and not do that. Where were we? We were on indicators. And this time I want an ammeter. And we'll do a horizontal ammeter. Again, notice the polarization on it. So you want to make sure that it's in the circuit oriented the right way. And I'm going to try to put that ammeter like right into the circuit, like right here. Now you can actually notice how when I slide it up there, it actually creates a junction. So you can just embed it right in there. Or you can, sorry about that. You can connect it up with a wire, but it actually has to be in the circuit. So the ammeters are definitely trickier because you have to like dismantle a piece of the circuit. And now when I hit play, it's telling me like we're getting the other circuit running at the same time, but it's telling me that I have 1.243 milliamps running through the entire circuit. And so you're going to place an ammeter into your circuit and give the overall current in the circuit, and then pick one of the branches. So pretty much what I want you to do is I want you to demonstrate that you know how to put the ammeter into the circuit so it goes in series with the components, where like the voltmeter is in parallel with the component, and to demonstrate that you have some proficiency at Multisim, and you can get into the circuit and you can delete stuff. So I'm going to go ahead and pause this. This can be so stinking annoying. If you have a simulation running, it will prevent you from doing all kinds of other stuff. So if you get locked out of a simulation, especially if you have multiple designs up, because I would have like 6 or 7 designs up during my training, I would have all kinds of garbage going on. And I would have one simulator going we'd look at like LEDs in the simulator, and I would forget, there's my accent. I would forget that it was running, and then I'd get locked out of something else. And you have, so try to remember to turn off your simulation before you click onto anything. All right, I'm going to measure the current in this branch just because that's where I have some space. And I'll go ahead and like one of these is indicators, not a diode. Indicator, there it is. And we'll just go ahead, we'll use another ammeter. Now, remember that I have the positive current, it's coming from the left. So if I put this in like this, it's probably going to tell me that like my current is negative, if it's even that friendly. So we'll just kind of see what that does. So let's do this. Yeah, it's telling me I have negative current. And the reason it's telling me I have that negative current is because I have the plus and the minus backwards from the orientation in the circuit. So if I wanted to change that, I can flip horizontally, and now we should be good to go with a positive current. So I've changed the orientation on that. So that's what you're going to do for step 7. Except with a different circuit than that one, so you can't actually screenshot that. And then for steps 8 and 9, you are going to physically breadboard them. So basically, activity 1.1.5 is we do the hand calculations on paper, then we practice using this simulation of the circuit, and then we'll breadboard the circuit. Don't expect all the numbers to come out exactly the same because life is not that friendly to us. But this tutorial was to help any students who were absent from like us doing this together as a class, or you were present in class, but you need just another refresher on it. So I really hope that this tutorial helped out with that.